So I'm getting a little further along on the 3-axis CNC cutting table. Today I'll do another short video of what I have going on. I've already did one previously explaining the drives. And in detail, this is the CNC control card, and it's USB. It takes a USB printer cable to a standard USB cable to a very small, minimal size laptop. Because the laptop really doesn't support a whole lot in terms of driving the actual CNC mechanics. The CNC drivers down here are what really drive it, and there's 3 drives in here, individual, one for X, Y, and Z, to represent each of the 3 axes. And if you come down here, you can see there's dip switch settings on here, and I'll try and focus in, see maybe can get an okay shot of those and where they're at. Incidentally, where I am at, if you come down here to the tables, we can see that on the tables themselves that there are different settings for the dip switches to drive the axis. Now incidentally, I am actually set on the 12,000 pulses per unit. So we're running actually the 12,800 pulses per unit. So that's some pretty good micro stepping, and these drives actually handle that just fine. They're I bought them out of China, one-time motors, I believe, but they perform very well. So I actually have a Max travel program that I have on here. I'll run that for you, and you'll see these will run. These stepper motors will rapid traverse at about 80 inches a minute, which is you know, for non-closed loop stepper motors, that's not too shabby. Generally, I don't cut things much faster than that anyway when I'm milling, even on the larger mills that we have in the shop here, or the Mazak. Now the Mazak's pretty quick, that's a lathe. When it comes to milling, I'm generally running half-inch end mills at about 4,000 RPMs, 4,200, at around between 40 and 60 inches a minute max. So really the 80 inches a minute for this machine is also more than sufficient for doing most aluminum, plastics, and wood parts that a person can do with this system. So anyway, what I'm going to go ahead and do is I'm going to rewind the G-code. This thing doesn't focus terribly well, but right now I'm rewinding that G-code up on the left-hand corner there. You see that's rewound. And then I'm going to come over here to basically where it says go to Z. I'm going to click on that, and that will run us back to our fixture home position. And when you step back here, you can see the machine coming on back. And I actually have it set to just come up and touch my limit switches. And you can see, if I zoom in there, that we're just right there touching the edge of the plastic on that plunger. And of course I've got one on the opposite side. You can't see the Y very well, but it's the same situation there. And then I have the Z picking up a half-inch, which will come up and touch that one. And I can run this program for several hours and no steps are missed. So we're running 5 I believe 5mm pitch rolled ball screws on the mechanics. So now we're back and zeroed out. You can see we're zeroed out on that. Machine coordinates from my homing switches is I'm actually in the negative direction, touching right up against the edge of those switches. And so that's your fixture offset. Let's go ahead and hit the cycle start. We'll watch it run here. Really hard to see with the reflection. There we go, cycle start. So the Z picked up, and you can see the Z just comes up and just kisses the bottom of that limit switch right there. I'll run diagonal length of the table. Then I have a program to run the Z up and down, just like that, and then it picks it right back up, and then it's going to move along diagonally back to the 0,0, and then it'll do some other moves. And I've got this program copied the G-code over and over, so it'll run for almost 2 hours non-stop, each time just coming right back over here to the switch. It's stopping right on the edge of it. And it's going to run across there. Now it'll run diagonal the other direction on the table. Not very exciting, but it's a great way to get your motors tuned and check your missteps. So excellent torque. These are 425 ounce inch NEMA 23 stepper motors, which seem to be more than adequate for this size table. Thanks for watching.